Welcome to the Unitary Fund Micro-Grant Winner video series. Today we're featuring Pedro Rivero of QRAND, an open source Python library for quantum random number generation. So, Pedro, maybe you could tell me a bit about your educational and or professional background prior to winning the micro-grant?
Sure. So by the time I received the grant, I was a PhD candidate in quantum computing at the Illinois Institute of Technology in Chicago. And prior to that, I had studied a bachelor's and master's in aerospace engineering. So for my thesis, just years before I received the grant, I was actually doing research at Argonne National Lab on simulating nuclear physics with quantum computers. So I had kind of a little bit of background on quantum computing already.
All right, very nice. And what was the problem statement of your project?
So what I wanted to do with this project basically was to build an efficient multi-protocol and multi-platform digital quantum random number generator framework. This was meant to be able to produce random numbers according to different probability distributions, which is a problem which is actually pretty hard to do. But we wanted to kind of come up with a solution that used both our classical capabilities for converting uniform distributions to whatever other distribution you want, with the ability to produce pure random numbers with quantum computers.
And so this was a library then that you created? Maybe you could say a little bit about the open source software part of it.
Of course, yeah. So this framework was actually called QRAND, and the whole idea here is that we just set up an architecture that allows you to both create and use different protocols which are already created for you in order to produce random numbers. And these random numbers are originally just uniformly distributed, right? Then we introduce an interface with NumPy that allows you to convert that uniform distribution to whatever other distribution you want. That's how we actually managed to get these results. And on top of that, we also provide compatibility with different backend providers like IBM qiskit, Google cirq, and Microsoft's qsharp.
Super cool. Everyone definitely check out QRAND. Yeah, so maybe you could say a little bit about the skills and experience that you gained from executing the project.
Well, I actually gained a ton of different skills and experience for this because, again, I was doing my PhD in physics, so I was mostly aware of the physical challenges of what I was doing, but not so much from the developer point of view. And this was actually a really great kind of starting point for me, although I already knew how to program basically, but not at a software developer level. So I learned a lot. I learned from just expand my knowledge on basic Python and core capabilities of the programming language, to things like type annotations. In terms of software design, I learned design patterns, which are amazing whenever you want to create any open source project. I learned about software architecture, solid principles for just clean coding. And then I also learned a lot of software tools like Git and GitHub, which I was already familiar with it, but I guess when you're trying to deploy something that everyone needs to use or can use or have to reference somehow, you need to do it at a whole different level, right?
Absolutely.
I learned about CI/CD, like with tools like GitHub Actions, and then also about Poetry and other build and release systems, PyTest, pre-commit, Black, and all these different tools that are used with Python. That's from a software developer point of view. Of course, on top of that, I also learned a lot about quantum computing, which it's a really broad field, and it's hard to be able to know everything about it. So in this case, I learned a lot about just familiarity with the different quantum computing solutions that are out there in the market, because prior to doing this project, I was only familiar with qiskit. I learned a lot about, and gained a lot of understanding of the quantum computing stack. When we're doing research, we usually work always at the same level of abstraction. But the moment that you need to provide, support for a software like this one, you really need to be able to move across the stack and at different levels, right? So So that was also a major gain for me. And last but not least, I learned about different quantum random number generation protocols that are out there, their pros, their cons, and the requirements, right? Why we can implement some of them, why some of them are kind of farther down in the future, and what can be done to get there faster.
Very cool. Yeah. So full stack quantum computing, pretty exciting. And then, yeah, helped you also maybe deepen your research a bit. Awesome. And so, how have you built on the results that you got from the project and the experience you gained since the project's completion?
So when we released the first MVP, it was actually a very basic thing, right? The only thing that it was doing was just, it was providing this interface with NumPy that I was talking about. It was connecting to IBM's backend, and it could produce sequences of random bits in a pretty efficient manner. We were actually using some caching technique where we just made calls in an efficient manner to the backends in order to retrieve as many bits, random bits as possible. And then we were storing them locally so that whenever we need to produce a different number, we didn't need to wait as long as people usually need to wait, just to get a few bits of randomness, right? On top of that, I started developing all of the architecture to allow for cross-plugin, and that was implemented after the first MVP. And once that was in place, I started considering the option of, hey, I'm just using like a very, very basic random number generation protocol, right? Just throw in a bunch of Hadamard's, make measurements, there you go, right? But that's very naive also, and there are a lot of ways and smart ways of producing random numbers in a way where you're harnessing entanglement and other nice features of quantum computing in order to have, I guess, enhanced features with your probability distributions, right? So I started exploring the whole, hey, let's have a way or provide even a framework so that users can actually create their own protocols and test them on different backends. And so that's how I expanded. And from there, I've just been working on quantum development. And right now I'm working for IBM as a quantum developer. So I guess it turned out pretty good for me.
Great. Yeah. Well, thanks very much. Yeah, very interesting stuff. And yeah, encourage everyone to take a look at QRAND and potentially contribute.
Sure, thank you very much, and feel free to reach out if you have any questions or want any walkthrough or whatever. Just I'm around in GitHub all the time. So
All right, will do.